Hey everyone, welcome to another video. Now, in the last video from this topic of year 8 measurement, we looked at defining Pythagoras' theorem and we looked at a proof for deriving this, for coming up with the equation that we got to at the end of the video. Now, in this video, I want to use that equation we've come up with and apply it to some questions. So this video and the next, we're going to be looking at using Pythagoras' theorem. So just a reminder, the theorem we came up with, so the sort of formula for Pythagoras' theorem was a squared plus b squared equals c squared. So in essence, if I square one of my smaller sides, I square another one of my smaller sides, and I add them together, it's going to be the same as squaring this side. Now, it's important to note there's something very special about this side C. This is what we call the hypotenuse, the longest side that opposes my right angle. So I'm going to label that actually because it's a pretty important thing to remember, and we can use this information when we sense check our answer. So hypotenuse, and this is my longest side. So here I'm going to use the information from my question. So I have, and if you remember from the previous video, it doesn't matter which of these two sides we select to be A or B. They just mean both of the smaller sides. The c squared, the hypotenuse, is always going to be on its own in the equation. So to find this, we are going to, let's let 3 be my A, my side A. We have 3 squared plus, and 4 squared here for my B equals c squared. Now this just looks like an equation that we have looked at in the past and we can think about solving. So what I'm going to do is I have two numbers here, 3 squared and 4 squared, which I can rewrite as 9 and 16, because squaring a number is just the same as multiplying it by itself. So I get 25 equals c squared. Now, what I found, it's important to note here, I haven't found c, I found what c squared, what c multiplied by itself is. And you may remember from solving equations in this year, this is an equation which is squared. This is one of these simple quadratic equations that we found, that we looked at, I should say. So I can say that c is what I get when I take if I want to undo the squaring, I can take the square root of both sides. So if I take the square root of c squared, I get c. If I take the square root of 25, well, I get the number that multiplied itself to give me 25. And 25 is a perfect square, so we have a number. Now, just so I don't contradict myself from the solving simple quadratic equations video, but I get two solutions here. I get 5 and I get -5. Because when we square a number, 5 times 5 gives me 25, but also -5 times -5 also gives me 25. But this is in the topic of measurement. So anytime we measure at least lengths, so for example, 3 meters, 4 meters, c meters, I can't have a negative meter measurement. So if I measure with a ruler or a tape measure something 3 meters and 4 meters, I'm not going to have negative meters when I measure. So I'm going to ignore this solution, because our answers here depend on context. We are in the context of measurement, and when we measure lengths, we want positive answers. So my C is going to be 5 meters here. That is how we can use Pythagoras' theorem. Now, what we're going to do here, because using this equation confuses a lot of students, I found. So once we finish all of these, I'm going to do what's called a sense check. Does the answer make sense in the context of the question? Now, my answer is 5 meters, and the solution I found, what my 5 meters is, that's the length of the hypotenuse, which is the longest side. So I just want to double check, well, is the length I found, 5 meters, the longest length out of my 3? And I can see here it is, because I have 3 meters and 4 meters. So my answer's correct. It makes sense because I'm finding the hypotenuse. I'm expecting the length I find to be the longest. Now let's do another one here. And let me give some units to this as well. So we'll say that's 9 centimeters, 7 centimeters, C centimeters. And I want to find, once again, the length of my hypotenuse, my longest side. So when I find this answer, I'm expecting it to be bigger than 9 and bigger than 7, because it's my longest side. That's just the definition of the hypotenuse. So what I'm going to do here, once again, I'm going to write out Pythagoras' theorem, which tells me that c squared equals a squared plus b squared. Doesn't matter which order we write it in. Some people like to write a squared plus b squared first and then that on the right-hand side. But if things equal each other for any equation, it doesn't matter what side of the equal sign we put it, because that's just showing that one side is the same as the other, regardless of the positioning. So all I'm going to do here, once again, is I'm going to substitute my values here. So I'm going to put, for example, 9 where my a is. So c squared equals 9 squared plus my b squared, my 7 squared here. And now I have, this is like saying, what's 9 times 9? Plus 7 times 7. Because if you remember, squaring a number is a shorthand for multiplying the number by itself. So when I do this, if I pop that into a calculator, I'm going to get 130. And now I have, once again, not c equaling 130, c squared equaling 130. So I can take the square root of both sides here. And what I end up with is, if I take the square root of c squared, that's going to undo the squaring. That's going to give me back what the number was that multiplied by itself to give me c squared, which is c. And I'm going to square root 130. Now, this 130, this is not a perfect square. You can even think back to your times tables. There's no number that multiplies by itself to give me 130. So my answer's not going to be too nice. But that's okay, because with any measurement, we can just round this up. So once I pop that in my calculator, I'm just going to get 11.4 centimeters, just rounded to 1 decimal place. And let's do a sense check again. Is my side 11.4 bigger than my other two sides? Well, yes, it is. It's bigger than 9, it's bigger than 7, and we would expect it to be, because I'm finding the hypotenuse, the longest side that opposes the right angle here. So if we got, this is how you can apply this, for example, in a test or in questions you're doing at home. If my answer I got was smaller than 9 or 7, something's gone wrong. Either I've inputted it into my calculator wrong, I've done my working out slightly wrong, but we can always do this sense check. Once you get your answer, does it make sense? Well, this one does, as well as the previous one, because in both questions, we're finding the longest length, the length of the hypotenuse. So this answer checks out. Now that's how we can use Pythagoras' theorem to find the length of the hypotenuse. And the next video, we're going to talk about using this same theorem to find the length of the smaller sides of my right angle triangle. So one's like this, one's like this. We're looking for the smaller sides of my right angle triangle. But I'll see you guys in that video, and thank you so much for watching.